Hi guys, this is section 7.1, integration by parts. And we use integration by parts because U substitution or 6.1 rules won't work anymore. And so here's the formula. It's the integral of two functions. We're going to call one of them U and dv. You'll definitely know your U's and your V's. It's going to be the formula is U times V minus the integral of V times du. Okay. All right. So it's different. They're U's, but it's different from U substitution. So what this is saying is that in my original integral, there are going to be two functions. So we're going to call one of them U and one of them dv. Okay. All right. So the first thing we do is we pick U. And U is always the logarithmic function if there's one there. If there is no logarithmic function, then U is equal to the algebraic function. Okay, and I know this isn't going to make a lot of sense until, let's see if I can get this thing to, do better. Can y'all see that better? Okay. All right, and then dv is the function in the original problem that you didn't pick. So dv is whatever is left over. Okay. All right. So once you pick those two things, like you see that in your formula, U and dv are in your original problem. We're still going to use U, but we need V. We don't have it. And we need du. Okay, so from these two things, we're going to find the rest of what we need. And I know this will be a lot easier for you once we have an example, so just bear with me. The third thing we're going to do is find du, which is what? The derivative of u. And then we're going to find, so we have dv and we have u. We know how to find du. That means the derivative of u, right? And then we have dv. So to find v, we have to find the antiderivative of dv. Okay. All right. So here are my steps. Okay. So let's make sure we have all of our steps. And I'm going to put these on Blackboard as well. But before we continue, I want to show you an example and show you how I use the steps. Okay, so let's say we have the example. We have the integral of 3x e to the 2x dx. And it tells me to use integration by parts, okay, to evaluate the indefinite integral. And it'll always tell us that. So we don't have to decide if we need to use parts or not. And if you'll notice that we don't have numbers there, so we're going to end with plus c. okay? All right, so here we go. If I look at this function, I see 3x is one of my functions and e to the 2x is another. So that's what I mean by I have two functions in my original problem. Now 3x is an algebraic function and e to the 2x is the exponential function, okay? All right, so the first step is to pick u. Let's do this. See if my steps make sense. This is just like regular class. This is what we would be doing. So in my integration by parts, it says u and dv sit in your problem. So one of these is u and one of them is dv, okay? Well, it tells me that u, when we pick u, bear with me, u is always the ln, okay? If it's there, if there's a ln in your original problem, then u is always the ln. So I'll look at my original problem and there is no ln. So then I'll let u be the algebraic function. So in this example, my u is 3x, okay? And remember, u and dv both sit in your problem, okay? So I've picked my u, now I have to find my dv. Okay, so dv is whatever is left over in the original problem. So dv, and notice I go side to side because I'm going to find my du under here and I'm going to find my v under here. So dv is whatever's left over in the original problem. So if my u is 3x, my dv is e to the 2x. dx is everything that's left over. Okay, I'll have to turn my phone off. So here we go. All right, so now what is du? It is 3 dx. Okay, and what is v? Okay, so to find v, I have the derivative, so how do I find v? V is going to be the antiderivative. Okay, so those are my two steps. So here's what we have. We're trying to get it all in. So du is the derivative of u. So we found that. And v is the antiderivative of dv. So the antiderivative of e to the 2x dx. So the antiderivative of e to the 2x dx is just from my 6.1 rule. So it's e to the 2x divided by 2. Okay, plus c, but we're going to just wait on that. Okay. All right, so we've got everything I need. And so here are my steps so far, my wrinkly steps, okay? So I did all of those, and now I'm just going to plug it into my formula. And from up there, my formula is the integral of u times dv is u times v minus the integral of v times du. Okay, so we're just going to take everything we have from our example and plug it in. Okay, so here we go. There is my formula. So we're going to I'll just write it again. So the integration by parts formula is u times v minus the integral of v times du. So let's plug it in. U is 3x. V is e to the 2x over 2. And we're done with this part of the problem. But minus the integral of v e to the 2x over 2 times du, which is 3 dx. So you see, I just took everything from up there and plugged it in. Okay. All right, so my next step is, and really it's not necessary for the E's, but I do it anyway because I have to do it for the LN, so I just want to do it for everything, and it makes it a little easier. I'm going to simplify V times du before I integrate. Before I integrate. Okay, so simplify V times du. So let's look at what that looks like. Okay, a little wonky thing. So the left-hand side remains the same, 3x e to the 2x divided by 2 minus the integral. Remember, this is going to be a 6.1. We're either going to add 1 and divide, or we're going to do e to the kx. So when I rewrite e to the 2x times 3, I'm just going to move the 3 over. So we're used to looking at it as 3 over 2 e to the 2x dx. I just rewrote that, okay? Now, remember, 3x e to the 2x over 2 minus the integral. Let's look at our 6.1 rule. The integral of a constant times e to the 2x dx is what? Let's bring this along. It's the constant times e to the 2x divided by 2 plus c, right? Or kx. So let's put that together. So it's 3x. Ooh. Here we go. 3x e to the 2x over 2 minus, so my constant is 3/2 e to the 2x, and I divide by 2 again, plus c. Okay, so I just integrated 3/2 e to the 2x, which is 3/2 e to the 2x divided by 2. All right, and then I'm going to multiply those twos together, and I have my final answer. So my final answer is going to be 3x e to the 2x over 2 minus 3 e to the 2x over 4 plus c. And I will get these problems online for you, and I'll also work the practice. The practice problems are already there. So what we've done is we've culled down, we've thrown out some problems, so you won't have as much to do since we lost about a week of school. So that's example 1, using e's. So when I go back to my steps, okay, I simplified that. Remember, I moved the 3 over. That's what I mean by simplify here. I said, oh, well, let's just move the 3 in front and call it 3/2 e to the 2x. And then after I simplify that, I integrate it. So now the last step is to integrate v times du. Okay. All right, so those are all my steps. If you want to write those down, there it is, the formula. I pick u and dv, set in my problem, and then I find my derivative from u, and I find my antiderivative from dv. I plug it into the formula. I simplify this part. Then I integrate that part, and I'm done. Okay, all right, so that's one example. Let's look at another example with an ln. So example 2. And we'll use our steps. You know me and my steps. Okay, so example 2. So the integral of, let's say, x squared times the ln of x dx. Okay, and again, it says use integration by parts to find the indefinite integral. Okay, all right, so remember, u and dv sit in the problem. So let's look at our steps again. Okay, so here's my formula for integration by parts. U and dv sit in the problem. So we always pick u first. U will be the logarithmic function if it is there. So let's go look. All right, so here I have two functions, x squared and the ln of x. Okay, so one's an algebraic and one is a logarithmic function. Okay, so u will be the logarithmic function. Okay, and then dv is whatever is left over in my original problem. Okay, and that's really the most important step. Okay, so here we go. Pick u. U is the logarithm if it's there. Okay, and dv is whatever's left over in the original problem. All right, so how do we find du? We take the derivative of u and then we integrate dv. So let's go do that. Well, let's be reminded of a couple of things. Let's go do this. This is a Math 267. We'll call it refresh. Okay. All right. So if y is equal to the ln of a function, okay, then the derivative y prime is the derivative of the function over the function. Okay, so the derivative of an ln doesn't have an ln in it. Okay, all right, so if y is equal to the ln of x, then we have y prime is the derivative of x over x dx. Okay, and then sometimes in the next problem we'll have a constant in front of that x. So if y is equal to, say, like the ln of 3x, okay, then y prime is the derivative of 3x over 3x. And we'll just go ahead and simplify that as 1 over x dx. So every derivative, so let's say in general, if y is equal to the ln of any constant times x, then the derivative is going to be the derivative of a constant times x over the constant times x. So it's always going to be 1 over x dx. So in 7.1, the derivative of the ln is always going to be 1 over x dx. Okay, so let's get back to our problem. That's my refresh. I'll post all this online eventually. All right, so let's look at my problem. Okay, so here we are. Let me get my steps. They're under here. Okay. All right, so here's my problem. So in integration by parts, we know that two functions. Now let me just say this about the ln of x. That's one function. You can't say x squared is 1, ln's 1, and x is 1. The x is the argument of the ln, so those guys stay together. We can't ever move them. And so it says I've picked u. If there's an ln, u has to be the ln, and dv is whatever's left over. So we've already got that part done. Okay. And then we find the derivative of u. So we have to find du and we have to find v. Okay, so to find du, d is the derivative, so it's the derivative of x over x. Okay, and v is the antiderivative of x squared dx. So a lot of people make the mistake and call that 2x. But remember, this is the derivative of v. So we have to do our add 1 and divide from 6.1. V is x cubed over 3. okay, plus c. But we're going to just put that in at the end. All right, so 1, 2, 3, 4. Step number 5 says plug it into your formula. Okay. All right, so I have my u, which is the ln of x, okay, u times v, and here's my v, which is x cubed over 3, okay. We're done with that part, completely done, minus the integral of v, which is x cubed over 3 times du, which is 1 over x dx. Okay, so we have to address this situation right here, okay? All right, so I'm going to go do a little algebra review, because if I have the integral of x cubed over 3 times 1 over x dx, I don't have a product rule, right? So I have to algebraically simplify before integrating. Okay, and whenever you have an ln in your problem, you're always going to have times 1 over x, times 1 over x, times 1 over x. So really, that's x cubed times 1 over 3x dx, okay? Which is the same thing as what? When you divide like bases, right? You subtract your exponent. So I have 3 x's on top and 1 on the bottom. What's left over, right? So I have x squared over 3 dx. So we always have to simplify that, okay? But don't be scared of it. I multiply by 1 over x, so I have 3 x's on top and 1 on the bottom. 3 x's on top and 1 on the bottom just leaves me 2 on top, and I bring that 3 along. Okay? All right. So let's go back to our problem. So now we know that we have the ln of x times x cubed over 3 minus the integral. Now, mind you, we just simplified this. We haven't integrated it, so I keep my integral sign, and I know that now that's what? The integral of x squared over 3 dx. And I'm going to use my 6.1 rules to integrate that, right? I'm going to add 1 and divide. All right, so if I, let's write that down, ln of x times x cubed over 3 minus, so how do I integrate x squared over 3, okay? So that's going to be, I add 1 to it, and my new exponent is 3, and I have to divide by 3. So that's going to be x cubed over 9 plus c. And the plus c is because in my original problem, I didn't have any numbers, okay? So when I simplified it, I got this, so I integrated. This is telling me to do 6.1. So I add 1, and I divide by my new exponent, so it just means I multiply those together. Okay? And then we're going to do one more example. Example 3. Actually, we're going to do 2 more examples. Okay. All right. So the integral of x times the ln of 5x dx. Okay. And it says use integration by parts. Okay, so when it says use integration by parts, I know that u and dv are sitting in my original problem. Okay, and let's go back to our steps. So there's my u and my dv sitting in my original problem. In my steps, I pick u. So u is always the ln. So here, u is the ln. Remember, we can't separate the ln and the 5x. So u is the ln of 5x. Okay. All right. And then what is dv? It's whatever's left over in the original problem. Okay. So dv is x dx. And we've got everything we need to find the rest of the stuff that goes into my formula. Okay. So let's do it. What's the derivative of u? We know that it's the derivative of 5x over 5x. And we said that would probably just be easier to call it 1 over x dx. Okay. And then v is going to be the antiderivative of x dx. Okay. So I have my du is 1 over x dx. And my v is the antiderivative. Remember, there's an understood 1, so I add 1 to it, and I get x squared over 2. So that's my antiderivative. Okay, so now I just have to plug it into my formula. So my formula is u times v minus the integral of v times du. So remember with the ln's, we're going to have to deal with this multiplication. We have to simplify and we have to integrate on this side. But once we put in u is the ln of 5x. That never changes. V is x squared over 2. And we're done with this left-hand side. Minus the integral of x squared over 2 times du, which is 1 over x dx. Okay. All right, so look at my steps. I plugged it into the formula and I simplify v times du before I integrate. So we talked about this before. So let's, the ln of 5x times x squared over 2 minus the integral. We haven't integrated. We haven't added 1 or divided or done e to the kx. So x squared over 2x. How are we going to simplify that? It's x squared over 2x dx. So we simplify. We haven't integrated it. So I have 2 x's on top and 1 on the bottom. It just leaves me x over 2 dx. And now we have to integrate using my 6.1 rules. And we're almost done. So we bring along the ln of 5x times x squared over 2 minus, all right, so we have, that's understood 1, right? So we add 1 to it. Our new exponent is 2, and we divide by 2, so that gives me x squared over 4 plus c. Okay. So those are the 2 ln problems, and we did an e problem. The thing about the e problems is that sometimes they have the negatives in them, and that kind of throws things off. So we're going to do an e problem with negatives, and then we're done with that 7.1. It's doable, right? We can do this. We can do this. All right, so let's do, and on one I saw it had a fractional exponent on e, so we're going to do that. Example 4, and we're done. All right, so the integral of negative 5x e to the negative 1/2 x. So let's just make it as ugly as we possibly can. Okay, negatives everywhere. That's how Hawks makes it hard, right? Okay, so we just got to watch our signs really when we're plugging in everything. So integration by parts, I know that U and DV sit in my problem, right? Let's go back to my steps. Integration by parts, U and DV sit in my problem. Okay, so one of my functions is negative 5x, and one of my functions is e to the negative 1/2 x. So which one is U and which one is DV? Okay, so U is always the ln, but you see there's no ln there. So then U is the algebraic function. So we let U be negative 5x. And so dv is whatever is left over. Okay. See, so U was didn't have an ln, so U is the algebraic function. And dv was whatever's left over in the original problem. So we have to find the derivative of u, and we have to find the antiderivative of v to get everything we need to put in my formula. So the derivative of u is negative 5 dx, and then v is the antiderivative of e to the negative 1/2 x dx. Okay. So v is e to the negative 1/2 x, and I divide by negative 1/2 or multiply by what? Negative 2. Okay. All right. So I've got everything. Okay. So let's do it. Let's plug it into my formula. So when you divide by negative 1/2, you invert and multiply by its reciprocal. So uv minus the integral of v times du. We're going to plug it into my formula. U is negative 5x, and v is negative 2. But if you write it like this, it looks like subtraction. So we're going to put parentheses around it. Okay. Minus the integral of v times du. So I say times, I'm just putting parentheses because it looked like subtraction. So look, negative 5x times negative 2 e to the negative 1/2 x. It just makes my life easier if I call it 10x e to the negative 1/2 x. And I'm done with that. Done with the left-hand side. Minus the integral. And so let's simplify this. Negative 2 times negative 5 is just 10 e to the negative 1/2 x. Right? Okay, so we have to integrate that e to the kx. Remember, the integral of a constant times e to the kx is going to be the constant times e to the kx divided by k. Okay, so I'm going to leave my left-hand side alone, minus 10 e to the negative 1/2 x divided by negative 1/2 plus c. So that's going to make that 10x e to the negative 1/2 x minus, divided by negative 1/2 means you multiply by negative 2. So let's just make that plus 20e to the negative 1/2 x plus c. Oh, maybe you should be able to see it. Okay, so what I did was when I integrate 10e to the negative 1/2 x, that's like ce to the kx is ce to the kx divided by k. And so the antiderivative of 10e to the negative 1/2 x is 10e to the negative 1/2 x divided by negative 1/2. But remember, we invert, multiply by negative 2. So let's make that positive. Divide by negative 1/2. So we invert and multiply by negative 2 times negative 10, and we'll just make it positive 20 e to the negative 1/2 x plus c. And that's 7.1, and I think that's really doable. But I'm a math teacher, so let's see what you think. And I'll post the problems on Blackboard, but I think you should be able to take these problems that I've done on this video and just go to your Hawks open up your homework, go to Certify, and try all these problems. You'll have examples of all of them, and never accept a strike. If you get stuck and have problems, then just take a picture and email it to me. And your quiz, when we assign it, is just going to be on this 7.1, this quiz 5. So let's see how we do. We're all in this together, just doing our best. And so my biggest hurdle is getting the video posted. So wish me luck, and I'll see y'all in a minute. Hang on. I want to say, hey, we're in this together. We can do it. 7.1, not so bad. We've thrown out a lot of hard stuff. So we're going to, we can do it. All right. You guys be safe, socially isolate, and let's get rid of this stupid virus. Okay. See you soon. Okay.